Here is the electric circuit and we are calculating the unknown voltage and current. We have the total voltage which is 18 volts. We have resistance R1, R2 and R3 which are 4 ohms, 6 ohm and 3 ohms respectively. To solve any kind of electric circuit, first we should know Ohm's law, which is V is equals to Ri. Voltage is equals to current times resistance. And in this case we use the concept of parallel resistors and series resistance. First we look after the two resistors R2 and R3 which are in parallel combination. We find the effective resistance of R2 and R3. As we know, R2 and R3 are in parallel combination. The current gets divided from point D as we can see, but the voltage remains same in R2 and R3. Now, as I know in a parallel combination, effective resistance can be derived from this formula. 1 by R effective is equals to 1 by R1 plus 1 by R2. Here 1 by R effective is equals to 1 by second resistance which was 6 ohm and third resistance which was 3 ohms. So I got effective resistance of 2 ohms. Now as we see R1 is in series with the effective resistance of R2 and R3. So as we know in a series combination of resistance, the resistance get added up, which is the total resistance of the circuit is equal to R effective, which is the effective resistance of R2 and R3 plus R1. So we get the effective resistance of the circuit as 2 plus 4 which is 6 ohms. Now as we find the effective resistance of the circuit, we use this Ohm's law again, which is V is equals to Ri. We know the voltage supplied was 18 volts. So 18 volts is the voltage supplied, 6 ohm is the resistance of the circuit times I. So we calculate I as 3 amperes. Similarly in R2 and R3, the effective resistance was 2 ohms and the total current is 3 ampere. So using Ohm's law, we have V is equals to Ri. So V is equals to 3 times 2, we get a 6 volts. That 6 volts goes to R2 and R3 as both of them are in parallel combination. Now applying Ohm's law individually for both of the resistance, we have for 6 ohm V is equals to Ri. We calculate the voltage as 6 volt, resistance as 6 ohm. So we get a current of 1 ampere. Similarly for the third resistance, we again apply Ohm's law, which is equals to V is equals to Ri. We know the voltage is 6 volts, resistance is 3 ohms, so the R3 is equals to 2 amperes. In the first resistance of 4 ohms, we found earlier that the current was 3 ampere. Again, as we know, by applying Ohm's law, V is equals to Ri, so the voltage is equals to 4 into 3, that is 12 volts. As we discussed this circuit above, we can see that by applying the concept of Ohm's law, concept of parallel and series resistance, we can find any unknown voltage, current or resistance in any kind of complex circuit.